Hey, I'm Michael Sigmund, and this is Lab 3, Magnetic Field of a Bar Magnet, for Professor Berger's Physics 2112 class. The purpose of this lab was to learn more about magnetic fields through observing the relationship between distance and the magnitude of the magnetic fields for both on and off axis. The two fundamental principles for this lab is the Biot-Savart law and the distance dependence equation, which can be written in two ways as you can see on the slide. So for this lab, first I laid my phone down on a table on top of a meter stick with a magnet at the end. I then moved the phone along the meter stick to record different distances and recorded the readings using a magnetometer on my phone. For the off-axis reading, I added another meter stick so that I can measure in both x and y directions and repeated the same steps. I did 5 different distances for the on-axis, and this is the data that I acquired. And using linear regression and the distance dependence equations, I found the value of n, which was negative 3.21, and the value of ln k, which was negative 14.8. So this is the data I got for the off-axis. And across 3 runs, the average distance perpendicular is 0.73 meters. And for this distance, the average force of the magnetic field was 1.76 e to the negative 4 Tesla. So this is my code. From line 35 to 38, I have implemented the Biot-Savart law into the function. And then from line 59 to 64, I created 6 different observation locations on the x, y, and z axis. So from line 70 to 98, I am finding the net magnetic force at all of those observation locations. And then later I'm adding all those together to find the net magnetic force on the total magnet. So when it is ran, you can see that this is the result we get. The on-axis is in blue and is in line with the magnet, while the off-axis is the purple, which points in the opposite direction and are to this below and above the magnet. And you can see that the off-axis is about half the magnitude of the on-axis. And finally, we have our 2 what-if questions. The first one is, what if you hadn't oriented your experiment to compensate for magnetic north and instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? So all of the readings would be skewed in a direction of magnetic north, which would make the readings less accurate. And the last what-if question is, what if you were to stick 2 identical magnets together end to end and ran the experiment again? How would you expect your measurements to differ? So the direction of the magnetic dipole moment would stay in the same direction. However, the magnitude of the magnetic field would approximately double from the original value.